Hey, what's up everybody? Welcome back to another 3D Hangout. I'm Noe, designer here at Adafruit. Joining me every week is Gordon Cole.
What's going on everybody? I'm PiGRRL, Rose Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing, DIY electronics, smash them together to make twin puns. Hello everybody in the chat room, thank you so much for joining us this week. We are streaming on different networks here. This is episode 159, entitled Twin Peaks? Twin Peaks. Yeah, so hello everybody in the chat room world. We are live streaming on YouTube, Facebook, Twitch, and Periscope. So hello everybody in that land. Let's go ahead and get started with the show. I'm going to start with today's coupon code. It's Music Maker.
That's right. Use Music Maker during checkout to get 10% off your order. Yeah. We also got some really sweet deals still going on till the end of the year.
Yeah, check it out. Go to adafruit.com/free to see what you can get. You spend more money, you get free stuff. We got while supplies last. Yeah. All the details and stuff, again, adafruit.com/free. We got a lot of content, so we're going to run through this. Let's see. Same-day delivery for fine folks in New York City. Go to adafruit.com/something to find that out. Just search. Google it. Adafruit Daily, adafruitdaily.com. Go to the website to learn more about that.
Which is Adafruit
Daily newsletters. Yeah. And then adafruit.com/newsletter. 1E.
And that's to get all your news on all the upcoming new products that are released every week. So make sure to subscribe to that.
And then there's Discord.
Hey, we got Discord chat going on, I believe, right? Is that Discord chat or is that YouTube?
That's YouTube, man.
It is.
Discord stopped us from doing that like 3 weeks ago.
But if you guys want to continue, the chat goes on 24/7, 360.
This is where we get cool stuff. Sorry, it's early in the morning here. I was going to say something to the effect of that's where we find a lot of content as well. People are sharing their projects. People are sharing their experiences and stuff.
Project help if you want to.
People are getting free things too. People are getting pins. People are getting help, CircuitPython help. A lot of CircuitPython developers in there hanging out. Lamar's in there too, hanging out. So after we drink our coffee, let's go ahead and get started with this week's project. This was a lot of fun. Working on it till the 11th hour.
It's one of those projects, yeah. So super fun project for this week. It is a MP3 player-based Feather, if you can get that properly switched over. This cute little guy, so it's based on Gordon Cole's hearing aid from Twin Peaks. We have access to our play, next, and power on button, as well as a slide switch. We have access to the SD card where all the storage for your music is held. And then on the bottom here, we have the headphone port and the USB port for recharging and for programming. We have a potentiometer on the top here so you can control your volume, and a nice little status LED on the bottom here to show the play status of this. So really love this project because it's a nice little wearable, and what coincidence, it's I think the 15th anniversary of the iPod. I know that Lamar has made MP3 players in the past before, but with our new Feather line, this thing is so tiny, super cool. You can kind of hear if I hold up the audio or the headphone to the microphone here. This thing is so awesome.
Yeah.
Wearable, nice little clip on the back here. Of course, we'll go all over the design details for that. If we take a look inside.
For those who don't know what a Feather, Pedro, what is a Feather?
So the Feather is our brand of a Arduino compatible microcontroller. Cool thing about this one is that it works with our brand new CircuitPython library as well, which is super cool because you can program everything by just loading it on your computer like a USB drive. So there's no need for like an external compiler. It's all just text that you type in to program it. Although this one is not running on CircuitPython, it's all done in just regular Arduino code just because of the speed that is required for playback and all that.
That's right. Nice portable, built-in USB charging, built-in JST for batteries. It's very nice. It's a nice little platform.
Yeah, so...
Oh, look, Jim says I switched from 2 Feathers and never went back to Unos.
Yeah.
So the Unos are a little bit more bigger. They're like credit card, about credit card size, a little bit bigger than that. Yeah.
So like I was saying before, we have the play functions on the side here. The pause will give you the nice little status indication on the LED. You can hit the on and off button here, which is like play and stop. And then skip track right there. So everything is nicely contained inside this little tiny enclosure. We have standoffs on the bottom here that are holding the Feather M0. And then right on top of that is the music maker shield, this guy right here. We have an SD card slot. You can store all your music on there, and a nice little way to hold all your buttons on the side, as well as the lid that is holding the potentiometer on there for the volume control.
Yep. Just to clarify, it isn't CircuitPython yet.
No.
But it is CircuitPython compatible. This was developed by Carter Nielsen, who might be in the chat room. He's definitely in Discord chat room.
Yeah, this is all his idea. He came up with the design and the programming for this. I just made a pretty box for it.
Yeah, but he developed it in C, Arduino C, using the VST1000 library, I believe.
It's the VS105.
105, okay, yeah. So you can get all those details in the learning guide, which we have over here. So if you want all the details on all the components, how to set up your Feather with the Arduino IDE, how to set up the libraries and stuff, all that is all listed out, thoroughly documented in our tutorial here, so you can check it out. So like Pedro's saying, the overview goes over all of the details that you want to take a look at, including prerequisite guides, kind of like the M0 Express. Every one of our products have a detailed guide that tell you everything about it, all the pinouts, how to power it, how to assemble it if it requires assembly, and how to set it up with CircuitPython, so you can get that started. So some of the parts that were used, obviously the Feather, the music maker, which fits on top of the Feather, some headers, some female headers, potentiometer, a external storage, so a micro SD card, a couple buttons, a switch, some LEDs, and a little LiPo battery, the 110 LiPo battery. So check that out. Those are all the parts you need. You can source them out yourself if you'd like, but we have them all over here and on the sidebar and listed here. So let's talk about the 3D printing part, since this is our realm. Not a lot of pieces to put this together.
Yeah, super simple to put together. It's just a nice little enclosure with the clip on the back, and then some replacement caps for the potentiometer. You have access to the Fusion 360 file, which we'll go into a little bit later in the show, and then just the little parts on how to orient your print. You don't need any support materials for this one, in the case anyway, because of the way that it's designed, which we'll touch base on in a little bit. But I just wanted to point out the way that all the button holders are held in place is with a bunch of these little, it looks like seats, doesn't it? With like little fillets on the bottom, and then the protrusions for all of the port openings are far enough to where like the cooling fans on most of the printers should be able to handle the overhangs that are happening for those. The only supports you're going to need are on the clip, which when we were doing the rehearsal for the show, we figured out that we actually could have just changed the design on the geometry for where the
if this was more like a wing
screw
or a
mounts
tab
are
like that, you wouldn't need supports, because then you would have kind of this 45-degree angle that would slope out. So that's a nice little tip there if you're making a clip or something like that. You need to print it up, and it's printed up ways, kind of like along the grain of the 3D print.
Yeah, so the orientation for this is laid down on the side so that you can increase the strength for when you are adding this to clothing or anything like that. It's going to make it stronger because, like you said, it is along the grain. These
type of things require pretty good bed adhesion, so I definitely recommend a nice brim. We didn't need a brim here, but I definitely, right? Would you recommend a brim?
For the bottom of the enclosure,
yeah, because it's so thin. It's got a little bit of surface area touching your bed. So,
although you could also, as you guys know, or have seen maybe in some of the behind the scenes, it's just printed on blue tape with some alcohol on top, and that does provide a very nice adhesion to prevent any warping on your boxed enclosure.
Yep. Cool. Clean up as usual. If you might not need clean up, but just a little bit, just kind of like a, hey, test out your holes and make sure that all the tolerances fit. Always want to do that before you start assembling. So just a little tip there. Okay, let's talk about the circuitry. We've got a circuit diagram. This shows you how everything's laid out on a breadboard. Again, this is from Carter, who put this together. All the pinouts can kind of change, any of the digital pinouts. So the buttons are going into pins 13, 12, and 11. You can change those up if you'd like. Doesn't really matter. The analog pins is going to the LED and, of course, the potentiometer, which controls the volume. That's pretty much it. A little resistor so you don't blow up the LED. I think that's it.
The most handiest thing about this is the ground rail that's on the prototyping area.
Yeah, that's what's great about these feathers is that you get like 4 or 5 grounds and a bunch of 3-volt pins. Because when you start wiring things together, like different components, you start running out of grounds, which is annoying. So it's nice that the prototype board, the area, the little prototype area can be used for more grounds.
You got some grounds to spare on this one.
Yeah, and they're already tied to ground. You don't have to tie them with a wire. They're already there. So it's really nice.
And for the past while, we've been adding the required lengths for each enclosure too. So all that is listed there as well. How long you need to cut.
Yeah, wire lengths. Yeah. Yeah, it's very important because if you have too short wires, it won't fit. They won't reach. If they're too long, it's going to be bulky.
Yeah, jumping into the code section of the guide, we have some basic setup on how to get your libraries and your board profiles for setting up on the Arduino IDE.
Okay.
And then we have the code that you can add in there.
Yep, this is actually, Carter's still kind of tweaking it a little bit. There's a little bit of problems with the volume. Is it still the thing? Is it a little bit different? Yeah, so it's kind of like subject to change, but you can check out the GitHub. We'll update this periodically, but for now, it's in a good stable state. And you can check out how he is, how he wrote everything. There's actually a nice little checker here in the bottom. This is kind of neat. Since Pedro's working on a Mac, and we intend to work on a Mac, there's this little extra stuff that Carter had to do to make sure that the hidden invisible files that the Mac OS makes isn't included in when the code is when it's kind of browsing stuff, music in the SD card. So this little name checker kind of makes sure that only certain file names work. So MP3, OGG. I'm not sure if WAV works, but definitely you want to use
WAV,
one of the
WMA,
two. All those work? And even as MIDI, yeah, this thing
FLAC.
has a lot of...
This decoder is really cool in terms of
the chip that's on the Music Maker FeatherWing. It's pretty nice. You can make tones and stuff too, as you can see. It's got a pretty decent library, so you can kind of...
You can turn it into a MIDI synth.
You could.
Cool.
You could absolutely do that.
Move on to the assembly code. I'm looking over at the chat here. I see Jim is asking, are we using the short headers?
Yeah.
It looks like he read the guide, because yes, we are using the short headers.
Yeah, the short headers, totally. Yeah, so this kind of probably won't work with the regular headers. So if you have a feather that already has regular headers, do yourself a favor, get more feathers. Get more feathers. I'm helping you out here. Music Maker, 10% off your order. Buy it now.
And if you already have one and you just want to remove those headers, you can get a hot air workstation for that as well.
Get 10% off that too.
Solder suck all those off and replace those off.
Sorry, that's so fun.
But no, this definitely does decrease the required size. I mean, it doesn't look like a lot, but when you're messing with something like, the enclosure of this, it does save.
Do you have them linked? We sell them as a kit. Yeah, short header, female kit, short header, male
That's
kit.
an important point. You do want to get male and female.
Yeah, it's a good bunch of them. They're like 50 cents. Get 10% off that. It's like, I don't know, 5 cents or something.
Yeah, so you just lay those on the breadboard, solder those up so they are nice and aligned. You want to make sure that they're not crooked, otherwise they are not going to fit.
And that's why the breadboard can help you have them perfectly aligned, so you want to have that.
Yeah. So we'll solder those, make sure all the connections are good, and then we're using these 8mm soft tactile buttons. My favorite buttons for this. We use these in all of the PiGRRL, the game systems that we designed.
Starting to, yes.
Yeah, it took quite a while to source these.
Yeah, I couldn't find them for months.
Yeah.
But we finally found them.
Yep,
yeah,
so
they're great.
Just a couple of modifications for fitting these into the little snap fit together parts that go inside of the enclosure. Just got to bend the legs back just a teeny bit so you can fit those through. And then we'll tin those up. The connections for these are diagonally across from each other.
That's right.
So just solder those.
If anyone knows, like if you're new to the learning system, you can click on any of these photos and they get bigger. So you can get them really big. Yeah, so if you can't really see and you want to see, just click on the photo.
And then you can click on the original right there.
Yeah, which is pretty big.
Zoom you up. Probably should have did that when we are close to one of the boards so you can see all the pins and all that.
Sure. Well, I mean, you got circuit diagram too, so you're going to know that.
For orientation.
Sure. Yep.
After that, we can start setting up, connecting all of the grounds to the rail there, the ground rail that we have on our prototyping area. Again, super handy to have all that space. You can also, if you needed other wires, you could like attach other wires to make more connections on that prototyping area to extend even more pins if you needed. So super handy to have.
Okay.
After that, we can start setting up our slide switch, and as mentioned before, we have all of the lengths required to reach the mounting spots inside of the enclosure.
Yeah.
So the thing that I'm doing here is after we've soldered the headers on, you can still piggyback off those, and I'm just connecting to the bottom there to get my enable and my ground pin. This is going to allow us to disable or switch the whole circuit off while we're charging, so we're not sort of wasting power while we are charging.
Yeah, and if you have time, heat shrink tubing. Cool. Next one.
Next one is inserting into the case. So this is actually one of your designs for mounting the slide switch into enclosures. It features 3 walls that hold it together, and then a slight cutaway inside of the wall that's protruding from. And you can't really see it in this angle here, but you'll have a nice little protrusion. So all you can, there you go. So you can just easily get to the slide switch. I like how tiny that little guy is there. Those were cool. And then we switch back over. And we can mount the 110 or 105 milliamp hour battery, whichever is being stocked right now. Scroll down.
Did you talk about mounting it with the 2.5
Oh yeah,
screws?
sorry. So yeah, we're using the 2.5 by 5 millimeter long M2 screws.
I love these screws. Did I say that? Like, these are my favorite screws.
So there's standoffs on the bottom. You can use 4 screws. I'm just using 2 of them diagonally.
Yeah, I started doing that too.
And then the way that we're mounting these buttons are these nice little holders that it looks like a seat. It goes in between them. You can slide these in at an angle, and it has a nice little cutaway, so you have enough room to protrude from on the other side of the enclosure. And what's cool about doing it this way is we don't need an additional like cap or anything like that. We don't have to have any more parts to it, since the protrusion is out enough to access the buttons.
Yeah, an actuator, like a button thing. Yeah, cap, I see what you mean. Cool. All right, so you get those in there, and then you can put in a battery.
Yeah, so you can either start soldering this before you snap fit all of the buttons in there. I did adjust the wire lengths for that, so you can. But in the tutorial here, I'm just soldering it while it's already mounted inside the case. Yeah, fairly easy to do. But if you have shaky hands,
tweezers. You definitely
you're gonna want to use tweezers.
My sausage fingers can't fit in this tiny little box.
Exactly. Yeah. Once all those IOs are soldered up, we can move on to modding the potentiometer, which is pretty much just ripping the
I didn't think you could pop these out, so that's kind of neat.
Neither did I until I tried. So we got a nice little 3D part that we can fit over that. You are going to need to switch it out just because of the thickness for the lid. You
can't access it. Yeah.
You won't be able to access the stock cap that comes on that knob. So we'll replace that, and of course for the colors that we want to use as well. And then we'll just solder all those guys up. Super easy to do.
Yeah. What's nice is, is the Music Maker has all those broken out pins, so you can access all the pins that are beneath it, right?
Yes.
Yeah, so that's nice. LED status. We got it.
Yeah, so for LED status, instead of using a regular like 3mm LED with a resistor hooked up to it, we can use something even smaller.
Service mount for the win.
LED sequins have the resistors built in, so you don't have to add any additional bulk to them. And they're so small, you don't even. I didn't even really need to design a mount for this because the wires that are hooked up to this is actually a little bit more heavier than the entire sequin itself. So that just pushes. Yeah, definitely. So this just pushes up against the enclosure to mount it very securely in place. And that's just going to act as our status.
Do you have a photo of that?
Yeah, it's right there. Oh, after I mount it, yeah.
Oh, right, because you got to mount this guy. Okay, cool. How does that work?
Following after that is the potentiometer, and there is a top and bottom for this. When you look at it, there'll just be a little bit more space on the bottom where the pins are, so just align that as shown in the picture there. And you're just going to want to gently bend those forward so they're nice and flat. They're not hitting.
Oh, they are. Oh, okay. Yeah. Yeah, you're right. Cool.
And just do a little bit of wire management there. I just use like Kapton tape to secure everything. You like using heat shrink around all of the wires to keep them all nice and organized. So you can either do that or just use Kapton tape to neatly join the corresponding wires all nice. Just bundle them up, really. So you just wire manage those around so they are not getting caught or kinked when you snap on the lid on top. After that, the last thing to do is attach the wearable clip that just slots into the back. And you can add a M2.5 by 5 millimeter long screw to secure that in place. And you have yourself a nice little working MP3 player.
Look at that. Super cool. And you can change the color of your LED if you want. We have a couple different colors in the LED sequin format.
Yeah, I got sidetracked on that one. You can get the multiple color pack of the sequins. I just thought the green might have matched a little better with the gold color PLA that we're using on
Is there an actual LED on Gordon's? This is the guy, by the way, if y'all don't know. I guess it's red. I don't know. It's probably at the top.
You're right. Yeah, I can see it.
It's not supposed to be the exact thing. It's just supposed to be inspired from. So, cool.
But at any rate, super cool with MP3. You can stick any type of audio formats on there. It'll play it nice. And super cool because you can sort of install this in like any area. Like if you have like a display or something like that. Yeah, very
interactive display.
Interactive display. If you're using it like as a soundboard, you know, super teeny tiny to play back audio. And the only thing I can mention about like some of the headphones that I tried this on is if you're using the ones with like a controller that's built into there, you are gonna have to sort of not plug this in all the way, just have it sticking out just a little bit for it to fully read the audio. Otherwise it'll come out like, I don't know if you guys have played with that before, where you like have the audio stuck out just a little bit where you can hear the like background or the layered tracks over music. Kind of a cool effect, but yeah, just keep that in mind. Don't plug it in all the way if you are using the...
Don't plug it in all the way?
Yeah, you have to take it out just a little bit.
Oh boy.
Yeah, for whatever reason. It's
all
the
headphones
way
now are TTRS or whatever.
Yeah, it's the 3-prong whatever thing on
data,
there. Data that's being sent through for doing all the controls. So just a thing to keep in mind. And then the 100 milliamp hour battery should last about 30 minutes, something like that. Since it's pretty skimpy. I could have put a 500 milliamp in there, but I just didn't want to increase the size of the thickness of it since
you're gonna pop it.
Yeah, I mean it would be that much more thicker, which you could easily do inside of the CAD, which is what I'll use as my segue. Jumping into Fusion 360.
We're gonna look at this layer by layer, folks. Get ready. So I fire up the CAD software that we use, named CAD software.
So you can get all the download links for the STLs or the Fusion files, which we should be looking at here. Super simple design. You can go through the entire timeline to check out how all of the parts were designed. All sketch driven, so if you want to update any of the dimensions on that, you can just type in the numbers and everything should scale with it, meaning all the holes, the mounts, everything should follow along any of the edits.
Yep.
Not user parameters. I didn't do that, but
I thought we did.
No.
I thought I put a gap in there for the tolerances. Anyway, what do we want to look at? The section analysis?
Yeah, if you take a look at the section analysis, this is what I was talking about in terms of the way that the
little chairs.
holders are
being held. It's like a spaceship. And there's the little chairs, and this is the window for the spaceship right there.
Yeah, so that's a little cutaway that actually pushes it in just a little bit forward to the wall so you can get the protrusion for the tactile buttons out of there.
I also like that you had to thin this out here, this and this, so that you can have more access, more closer. See the little
that's
indent?
what I'm talking
that kind of
about.
also holds the button in place.
Yeah, that's the cutaway for that.
No.
And then that's also the technique we're using for the slide switch.
Yeah,
so that
right here
protrudes a little bit there as well. And the challenge with that, can we take a look at how thick that is before
this guy?
Mm-hmm.
Yeah, I think we
or
can
any of them.
Flip or add a new one here, like this. We can get in there.
Just so we could take a look at what the minimal wall thickness is for 3D printing this on FDM. 0.6 should give you enough room for it to, you can't notice it, nice and sturdy, and you still are able to cut into the actual wall. So a nice little technique there for getting components to pop out of the enclosure.
Okay.
The other thing we want to take a look at is a new way that we figured out how to actually make these snap fit nubs. If you can point to what those are.
Yeah, so they're these guys here. So if you look at the, let's kind of get rid of this and then kind of reorient myself. So if you look at the case set itself, you'll notice that there's these little nubs here on the side. See that nub there? It's like a little triangular nub. And that nub there is actually optimized for 3D printing because it is at a 45-degree angle on the sides and on the top and bottoms. And then those are little nubs that lock into this lip that is on the lid. So if you look at the lid, there's these little, there's a lip, obviously. This is what you normally would see. Like, this is standard lip on the lid here, on the cover. And then we have this little triangular indentation, which actually is where the nub from the case snaps into. Well, in order to do that, you also need some material, some geometry to kind of go on the inside of the lid. So you can see how kind of this indentation follows this this profile of this little nub here. So what's cool is that we learned how to do this. You know, you can do this with like 100 different ways, but the more you do it, the more ways you find to do it with less steps. So that's kind of what we did here. Really, I think one of the main steps is that you can actually apply a shell to the lid here. So I'll show you an example of what it looks like. So this is what we had, you know, this little lid here. And it's fully solid here, right? This area here is fully solid. So you can just click on that and apply a shell. And Fusion's smart enough to create a shell and kind of make the shell go around this geometry here. See the little indentation there? So it's really, really smart. It's a better way than having to click on this, project a sketch, draw out an offset, extrude that offset, bring in more offsets to the inside here. It would take a lot of steps to make something that takes one feature. That is huge. And for everybody wondering, this is Autodesk Fusion 360. So that was really fun to learn, because now I don't have to do, you know, 100 different things to make this. And one last thing is that we added a little chamfer here so that the nub can actually seat in here and lock into this indentation much easier. So it's a small little chamfer. I believe it's like 0.6, 0.8. See that chamfer there? So you just select that edge, apply a chamfer on both edges there, and then you get this really nice thing. Because normally what happens is when you snap it in the first time, a little piece of plastic kind of breaks. It's like breaking skin or something.
First 1 or 2 layers always come off when you're snapping in the case.
Yeah.
So the reason we're using snap together cases or lids is because of the size of the enclosure is already starting to get restricting. Adding mounts for screwing thing takes up a ton of room inside. You
notice that there's a really nice gap here. There's about a 0.8 millimeter gap, and that's just kind of the tolerances that work well with the Type A machines. But they could be as low as 0.3, so you can change that if you want. Yeah,
your printer.
It's all in the sketch. So that's just a quick look at the CAD and this design. Hopefully this inspires folks who do CAD to, you know, some different ways to approach geometries and mounting features.
Yep, you can always rip these features out for any of your own designs as well. If you go through some of the sketches, you can just look at what the measurements are for all of those and redraw those to recreate in your custom enclosure.
Cool.
So definitely check that out. It is under the 3D printing page for that. Links for everything.
That's right. You can go to 3D printing, and a lot of people don't know really, but it's over here. This link, it says download Fusion 360 source, and when you go there, it'll load it in Autodesk's My Hub thing, and then you can download it by this button up here. There is a million, there's like 10 or so, SolidWorks, Inventor, SAT, STEP, DXF, STL, all the ones you like, OBJ, SketchUp. Google SketchUp, really? Wow. Pretty cool. I like the explosion view feature. It always explodes. Cool, so check it out. That's this week's project. And if you want to pick up any of the stuff in the shop, Music Maker, 10% off your order. Pushingtronics, hashtag Pushingtronics. All right, do we have any time for Q&A stuff? Or do we want to jump right into the next
probably
thing?
after, yeah.
All right, sorry, Hooks. If you got any questions, we'll answer them at the end of the show.
How do we get the feather? I know, there's always the question.
It's always like,
that's
oh,
always
they're too juicy.
interesting.
We want to answer them. Yeah. So how do you get the feather into Fusion? We modeled it. You can use any of our components in our designs. They are available in any of the designs. You download the Fusion file or whatever CAD thing, and then you can download it. I think we can share the link too, because they're all linked as well. Like the feather component, you can download that just in itself, or as an STL. People have asked for that as well before. I think the FeatherBox project has all of those feathers, so like the ESP, the Wi-Fi one, the standard M0 one, the BLE one. All of those are available on our GitHub, which we'll link in the description after the show. So Pedro's playing it on a little amplifier
DJing
here.
over here.
Yeah.
So super cool that you can have this as a nice little DJ setup. You know, just load a bunch of songs on there. Let's go through the operation of this.
Yeah. Yeah, the little shine is kind of just to let you know that the chip is working.
And you can disable that in the code as well.
Yeah.
Super cool for that.
Okay. So next up, these are Bartlebeats songs, by the way, and this is Bartlebeats' album Frequency. This is actually a vinyl record. This is a sleeve. Isn't that funny?
Yeah.
It's all music.
So the way we're doing the play out here is call back to our 20-watt amp we have in the shop. So it's just a simple little guy here, and it kind of goes together. Oh, we should probably combine these two projects into one, huh? Can we see this in the overhead?
Yeah, you can. I mean, the audience can.
Yeah, super cool.
But nice, I'm trying to pull up this.
Teeny tiny little enclosure.
So what am I talking about? This amp right here. We have this lovely 20 watts amp that's pretty powerful. It needs like 12 VDC and like 2000 milliamp current, which is kind of nice. So you can plug this into your outlet.
Yeah.
And yeah, you get 20 watts of juice. And the speakers themselves, we actually hacked up these old Apple Pro speakers. We just ripped out the connector and soldered them into these jumper cables, which is a project I wanted to do a while ago, but I never did it.
I like how the colors match for that. And then in the chat room, Yanni is saying that, hey, we could make our own little portable speaker or like microphone. You can attach all this and then have the microphone and then like the, you know how like when at events where people have the little microphone so they can speak and have like a megaphone, wearable megaphone. It's a cool idea there.
Just watch out for the feedback.
So again, super handy for like at a party or something you want to plug in. Sort of like a backup since a lot of the phones don't have any headphone jacks anymore.
That's funny. This is great for like embedded stuff, obviously.
Yeah. So super cool little playback player there.
Yeah.
Really like the retro.
Yeah, and huge shout out to Carter for coming up with the whole concept idea.
Yeah, for sticking through. This was definitely one of those projects where the designs and code is being updated in the 11th hour.
Yeah, I think, and like I said, there's still some more updates I think coming down, and hopefully we get this as a CircuitPython example, so folks.
Oh yeah, that'd be good. Yeah,
use that. Yeah,
I love this project. Check it out.
All right, cool. Now we're going to take a look at Shop Talk.
Yes.
Cool. I got a Shop Talk. Hey guys, you know, ever since I saw John Park's pinball project, which is right here, I got interested in the stuff that he's using. So he's using slotted aluminum extrusion. If you scroll down to this product page, you can see John Park's pinball. If you didn't see that, check it out. He did a live stream on it and a full tutorial on it. Basically used this 2020 extrusion to make the framing of this, and I've been thinking about doing something with it. So I finally figured out what I want to do with it. I made a hat holder. So what I needed to do was find out a way how to kind of model this thing, and I was looking around on McMaster-Carr, which is this great hardware place that you can have all sorts of hardware and stuff. So I looked, and they did have some 2020 extrusions, and I imported it in because you can do that. There's a plugin in Fusion that allows you to do that. It's like built into Fusion. So I modeled this like this wall mount because I wanted to mount one of the rails to my wall and put hats on it, and it was wrong. It was the wrong size. I didn't know that. They're actually not. They're not all created equally. So even though they're 2020 on the outside, on the inside those little slots actually differ. So I was searching around, and I found on GrabCAD this gentleman here, Mark Kenworthy, designed. Well, look at that, Adafruit 2020 extrusion profile. So I didn't have to like. I just downloaded his file. It's actually SolidWorks file, and I was like, "Oh, great, SolidWorks." There's no way that's going to work on my CAD package. Guess what? Fusion has native support for SolidWorks, which is awesome. So I imported that into my Fusion 360, and I made a little mount thing here, which I'll show you now. So I made a little mount. This guy here. I imported it in the component, so this is the profile. The measurements are spot on. They are exact. So the diameter and all the slots and stuff are all perfectly lined up. So I made this little like end cap piece that kind of fits into the wall, and that's kind of how it works. It just has two mounting holes, one at the bottom, one at the top. And then this area here is just a, it's just kind of like a gap here, so there's just a little bit of play. I think it's 0.2 millimeters. I set up a little user parameter, 0.3, so I can adjust this. So watch me, if I put 0.1, you'll see the thing grow a little bit. And then if I put it back to 0.3, you get a better visualization. Obviously I got one of the fillets broke, but that's fine. Just switch that back. There you go, you can see how the gap, so that's really important to do, is kind of like have a built-in tolerances user parameter. But anyway, one of the tips that I found out is that the way to print this guy, let me hide this for a second. The way to print this, this little guy here was, okay, if I print it flat on this side, I'm going to need support materials for these overhangs because they are 90-degree overhangs, right?
You print it on
Those
this
are problems.
side.
So I printed it on this side, and so I have this weird flaky platform. So you can see the thickness of this platform is 0.2 millimeters, which is one layer. So I made this kind of built-in support thing. I just cut it off. I just snap it away. And then I have chamfers here so that I have these like not too sharp corners. Could have probably put fillets, but it worked out really well. And I also did this little kind of tongue thing for my hat to hold out, and it's kind of using the same thing. I print it on this surface, and then this fillet here it just prints out nicely thanks to the cooling fan on the printer. And that's kind of my two little practical prints that I made. So what does it look like? It looks like this. So I mounted it to my wall with two wood screws. They're like really small and they're pointy, so they kind of self-tap. And there's a little bit of play, so I can move these and slot them around. And I can hang my hats, which is, I have a bunch of hats. And I was able to fit 4 hats there. And I probably want to do another one, so I have like 2 rows of them. So I don't know, it's just kind of a practical 3D print. A little bit of Fusion work. Again, huge shout out to Mark on GrabCAD, who uploaded the profile, so I didn't have to spend too much time making the profile and sketching out that profile for the 2020 extrusion, as it is a custom thing, I think. I don't know, maybe it's not custom. I couldn't find it on McMaster, like the right size. So, yeah.
Super handy.
Pretty cool. And shout out to John Park, who gave me the idea to use 2020. They've been in the shop for a long time. It's like product number 500 or something. And I just never used them and never had a need for them. But it's a really good, it's lightweight, it's super strong, it's aluminum. You can cut it with a hacksaw if you want. And
yeah, it comes with all the handy little cap end pieces. You don't have to print those out.
You kind of have to buy them separately.
Oh.
Yeah. So I put those end caps on there.
Yeah,
so you can grab those. You got a bunch of different things
too.
Yeah, so that's the whole point, is to kind of design and make your own. What I'll do is I'll actually probably upload these to Thingiverse so people can download this as an STL in case they don't have SolidWorks or Fusion and they want to do some CAD stuff, like Tinkercad, for example. You can import the STL and make your little cool gadget thing. But yeah, I think there's a lot of different use cases for this. So let me know if you guys have any ideas on that. If you want to pick up some 2020, Music Maker, 0% off.
Super code Music Maker expires at 11:59 p.m. tonight. Does not work on subscriptions or gift certificates.
That's right.
Be aware of that.
Cool. And that was one segment of Shop Talk. I think that was it for Shop Talk. We're running out of time, so we need to jump out of what we're working on to, I think, Community Makes. Is that cool?
Yeah, this week's Community Makes is
this guy.
It's a cool little huggable, cute ghost.
Yeah, this is awesome. So this is featured on Thingiverse right now. It's called the Cute Hug Me Ghost. It is designed by the folks over at G-Create, which is a 3D printing manufacturer, make big printers. And they kind of remixed this as a concept. This was like the original concept, and they were like, yeah, this is a really cool concept. So it's like your traditional ghost that's draped over, and he's completely hollow. There's nothing in it. So it's a really cool design. So we thought, hey, let's add some electronics to it.
So here's a little guy printed on the BCN Sigma.
Yeah.
So the only modification that I made to this was add a motor and an LED on the bottom with a nice little mount that holds in place both of these, and then a 3D printed weight to allow the sort of shaking that's going on for the movement that you see in the video. So I'll switch that on real quick. See that the nice little weight here is actually what's doing all the...
Whoa, this is so cool.
Yeah, and of course it looks way better at night.
It's a Bristle bot. So you folks heard of a Bristle bot. It's a great little project to get kids involved and started with STEM projects and technology in general, electronics. So really, really fun. It's using, like Pedro said, a toy DC motor, 9-volt battery, switch, and an LED and resistor. So it's pretty cool. I have all the files, or all the things are linked down below, all the things that we use in the product. Let's take a look at the video. So if you didn't see it, you should see it.
Of course, we're using the PLA PHA glow in the dark.
Yeah, so we'll get that extra bonus of glowing in the dark. Really cool. This is just dying to be a Bristle bot, you know?
Yeah.
Because it's all about the surface bottom surface that's touching the table, and it's just enough to vibrate. You definitely need a 9-volt battery. We tried this with a coin cell, didn't work. So you're basically and anything like a AA battery holder, it was just a little bit too big to get in there without modifying or scaling up the design, which I didn't want to do. Yeah. So this is 100% scale.
This is 100% scale. Yeah.
Cool.
You see here with the LED on, some black lights on it, you can kind of see the glow in the dark.
Oh, it's so, I don't know why glow in the dark doesn't work on camera, any camera. It's weird. It's the weirdest thing. It's like only the human eye can look at it.
You can see it there.
Oh, it's intense though in your human eye. It's like way better.
It's really bright.
All right, we're gonna try to pause this when it cycles here, but yeah, pretty fun. You want to use a fresh 9-volt battery as it tends to drain.
Yeah, if we take a look at the CAD though, if you ever want to use any of these mounts in any other project,
yeah, I would
take a look at that.
Take a look at that. We don't have it out yet, right?
No, we're going to the Fusion file to take a look at. Yeah, I'll upload this.
Yeah, that's what I meant. Sorry, I got a little bit here. All right, so it's actually pretty simple.
Here's a little profile for the 9-volt, and if you want, the DC motor as well.
DC motor.
So all they do is just snap into place. Yeah. And because of the components that are on the back, it won't slip through, even with all the vibration going on. And then you could just adjust that holder to whatever size you're mounting this inside of.
Tell me about the weight. How did you come up with this?
The weight was just a little bit of testing. I took a look at what the included horn that some of the
servo
servos
horn
have, and then just looked at, measured the tolerance for fitting it into the little, what's it called?
Obviously, kind of by default, it's just a shaft, the DC motor. It's just a shaft, and there's nothing to move anything. So you have to stick something to it in order for it to move.
Yeah. And I added this little side screw on
grub screw
on there, a little grub screw if you need it. But the tolerance was so tight that I didn't need it at all.
Yeah.
But definitely helps save material. And then you do want to print this with a 30% infill just to add that added weight to be able to actually shake. Because even though it looks small, there is a bit of weight on here, which is why we needed the 9-volt to give it enough power to actually move it. Because otherwise, it's just going to sit there making noise. It's not going to move at all.
Right.
But a cool little. Again, the whole theme for this entire Halloween season was 3D printing something, adding electronics to it, modifying it somehow.
We do this every week. Yeah, it's great.
To actually make it do something instead of just printing it out. And be like, oh, I made
you can add some life to it with a simple LED and a coin cell.
Exactly.
That was like the point. And then we gradually got a little bit more like, okay, let's add a servo.
Start adding motors.
Let's add a motor.
And it didn't take too much time. And just figuring out the tolerances for getting this guy to actually vibrate the entire thing. So definitely take that as a challenge for when you're 3D printing, you know, another bench or something.
Add something
Maybe
to it.
add lights to it.
Yeah,
you know?
a benchy Bristle bot would be pretty cool.
That would be pretty cool. Yeah, or make it actually float, or actually do some modification to it that sort of pushes you to actually learn something new instead of.
And I like how G-Create actually posted their original idea, because this is a custom design. They didn't remix this design.
Yeah, if you look at the remix,
but they still gave it a good shout out.
Yeah,
which is cool. This is the original Ghost Toy idea by TC Flea on Thingiverse. So shout outs to G-Create for being nice and doing that, crediting, because like we didn't come up with the idea, these guys did. Yeah. So that's why they posted it as a remix. Really cool.
Yep. So depending on how.
Well, I guess we'll have to post it as a remix and then upload our mount, because that's you designed it.
Yeah.
Yeah. Cool. And check out the video, please, because you know these videos take a lot. Not really, but you know what I mean. There's a lot of effort that goes in anything.
Yeah. So definitely challenge yourself to add some electronics to if you're doing these 3D printing time lapse type things. Add something more to it. Modify it.
Sweet.
And making it huge is not a modification. Add something to it. Modify it. Change some geometries.
Yeah. Music Maker.
Yes.
Pick up toy DC motor. Link down below in the shop. That's cool.
Yeah, I'm definitely going to have this roaming around on the sidewalks during Halloween.
Yeah, right. Let's step on it. Put it on the table over our candy thing. Add a proximity sensor so when you get close to it, it starts shaking at you. That'd be fun.
Moving on to the next segment.
Yeah.
Oh, actually, no, we're still in the segment. If you want to go
makes.
through some of the cool stuff we caught in the Discord channels this week.
First, we're going to look through some stuff we found. Scurried the internet, found some interesting projects we want to share with you, because we got about 10 minutes left in the show, so let's do that. First up, this is a really cool, you know we like light up swords. This is a sweet prop by Forrest L on Instructables. This is the light up sword from the Transistor game. This is the Transistor Sword.
Yeah, like
very cool. Combination of 3D printing and I think it's CNC milled.
Ooh, there's acrylic on there.
Yeah, nice documented Instructable here.
Nice.
So 3D printed stuff, some metal working it looks like. Yep, some wiring management stuff. I was about to say, like, you just crashed my website. Thanks a lot, Instructable ads. I need to install Pi-hole. I totally need to install Pi-hole. He designed it in Fusion 360 apparently. But yeah, this acrylic thing is super, super cool. So check that out. I'll have it linked below. I'm going to have to close this because, you know, the ads are killing me. Yeah. The ads are so great. The ads are too high up in here. Look at these ads, dude. They're killing my system. I need Pi-hole now. This is a cool design by Jonatron. Jonatron makes amazing projects. He is a resident at Instructables. He works at Instructables, but he's doing some great work. So this is a linear motion, 3D printed linear motion using like a screw or a drill. Yeah.
Oh, Kirby's saying if you log in, the ads go away. I think we have a
no.
If you log in,
that's not true. Kirby, that's not true, man. I log in all the time, and I get ads up the yin yang, up the wazoo.
We should demand some paid.
Yeah, give us money. This is a really awesome one from Chuck. So check out Chuck. If you're not subscribed to Chuck's channel, please do subscribe to him. He does this is what we do. He does 3D printing and electronics. This week he made, or probably last week, he made a jack-o'-lantern, a hidden-faced jack-o'-lantern. What is that? That is where the surface of the jack-o'-lantern looks really simple, and then on the inside is the face, and then you put an LED inside to light up and showcase that. So very, very cool. Hey, that's like a theme, right? Chuck, my man, doing it up really good. So check it out. He does Filament Fridays, CNC Sundays, all sorts of cool stuff. So check him out on the YouTubes. I have him linked below.
Subscribe.
This one is a make. So hey, do you guys remember last week I released a Circuit Playground case? Crazy Steve on Thingiverse posted his make and said it was very nice. I appreciate that. I haven't seen anyone else build it. He printed it on his CR10. Hey, I've heard of that printer. A lot of folks say good things about that printer. Very nice case. It came out fantastic. Well, thank you so much for sharing it, Crazy Steve. You're so crazy. This is a light up sword. This is your Guardian sword. This is a make posted by Hansaya on Thingiverse. Very, very cool. Printed on a Prusa i3 MK S2 0.2 resolution, 20% infill. I'm out of breath.
Very nice.
Next to his impressive Master Sword. It's like bigger.
Cool. What was the Master Sword version that we saw that you could light up?
We shared
so
it
cool, yeah.
last week, I think, or something.
Wow, I look at swords differently now. If it doesn't light up,
It's not a sword.
I don't think it's that cool. It
That's
just
funny.
needs to light up.
That's funny. Yeah. Or be made by Vulpin Props. By Vulpin. Or Core Geek. Or Punish Props. This is a Raspberry Pi Game Boy. This is the split version, so if you can't fit PiGRRL on your bed, you can download the split version. So thank you so much to Arzen1 for posting this and saying, hey, I figured I'd post the picture because it's going to take a minute for me to build it.
Very cool.
So very cool. She brings the pieces out.
So specifically, these are designed for something like the M3D Micro or the Monoprice Select.
Monoprice Select Mini.
Bot.
There it is. It's like a $150 printer.
Actually, no, it fits on the printer bots, right?
Yeah.
Not the smaller one.
No, the
Play.
printer bot, Simple Metal.
It'll fit on the Simple, yeah.
Cool. We got a lot of PiGRRL stuff today. This is another PiGRRL uploaded by Grow Pi on Thingiverse. Printed in black, TPE.
Ooh,
Not much info about it, but it looks really
Very
nice.
cool.
And it's fully working.
I like
think
the
it sanded
stealth
it.
black
Yeah, it looks
mode.
great. You got another make. This is Boomy, the boombox.
Yeah, it looks pretty good.
Yeah, this is self-painted. I kind of like that painted look. It looks pretty
It
neat.
looks like chalk almost.
Doesn't it?
It looks really cool.
Yeah, it looks really cool.
Huh.
So this is by JB Nuck
Mhm.
on Thingiverse. So thank you very much for posting that. Oh, he's got a GitHub project. Oh, that's sweet.
Oh. Some modifications
Yeah,
to
he
this.
added an IR sensor.
Very nice.
Sweet. And he put a bigger battery. Yeah, because I had to. My constraint was use all the stuff that comes with Adabox, but of course you can add stuff to it.
Mhm.
So, sweet. I did not know that. Sweet. This is so
Very
cool. This is really
awesome.
what we want to see, like this type of
Yes,
contribution.
modify,
Super sweet.
add
Yeah.
to the project.
Because I'm sure he's got
please.
like another GitHub repo, and in a way that's kind of like building up your kind of portfolio of your code. Let's check it out.
Very cool.
Sweet. So huge shout out to Joshua, actually, who made that. I'll link that down below too.
Very cool.
All right, so that was Boomy. Next one.
Super handy.
Yeah, this is the ESP. Everyone loves this thing, the Weather Station by Squizik. I believe he's the developer
This
who wrote that.
is a
It's great.
Gothic themed one.
Oh, there's a Gothic theme one next. Yeah, so this was just like a.
okay.
one
Oh,
here.
that's why I even thought about
Oh
it.
yeah. This was.
Check this one
Yeah,
out.
this was a great remix by an 8-year-old maker.
Very cool. Really love the
so-
design and theme of this. Very appropriate for this
Yeah.
holiday season.
Really cool.
Very cool.
Yeah. So you can check that out. Here's a nice picture of it. next to
Love
everything.
it.
It looks really cool. A nice theme. Nice paint job too. By Purple Orangey on Thingiverse. So those are just a couple things. I missed quite a few. There's a lot of blog posts that are going to be released tomorrow. So be sure to check those out.
Every hour on the hour, we'll have the printing post for that.
That's right. We're going to do Q&A and then we got to get out of here.
Yeah.
Q&A. Those are goblins and ghouls. So if you have any questions, guys, please let us know in the comments. We'll be in the Discord chat rooms as well. So if you want to hit us up after the shows, we'll be right there chilling.
Since one can Harry Potter make weather.
Cool. Kirby's going to send me a premium code, so I don't have to.
Yeah, I kind of wanted to
That's funny. What?
ask them, the Autodesk themselves, to send us a code, but whatever. Whatever's easier.
Thank you so much, guys, for joining us in the chat room. And you on Facebook over there? You wanna look
Yes,
at
I am Facebook.
Do we have
Shout
any
out to
Facebook?
everybody on
Anybody?
Facebook there. We got Manuel, Mark, Wall, and our very own Anthony Sherwood.
Hey, Anthony. Hey. Tony. Cool. So, that's it. That's all we got. Yeah, we got like 5 minutes left to the show, so if anybody has any questions. Since Harry Potter, can it make it weather? Yeah, I don't know.
It does look like a Harry Potter themed
It
weather
said Harry
station.
Potter on it. I don't know. No.
Yeah.
Can you scroll up and see if you missed any stuff?
I'm sure I did. I was just hoping
Yay, thank you
people
for the
would
comment,
post again.
Mattable. Mattam Bale. Mattam Bale. I should right click and say speech. I think I saw something about the hats and they were confusing because how do you plug a pie to it? I don't know.
Yeah, that was Kirby. Laura liking the tactile design buttons for the enclosure. Yes, these are super handy. Definitely picked some up. Took quite a while to actually source these.
Matambale. That's cool. You got to be careful when you turn this on because like I'm afraid the weight will just like snap my finger.
I made that small enough so that it wouldn't.
Ouch. Ouch. See, I'm going to burn the motor out. Stop. This is solid, man. Good job on that.
Yeah, we'll
Ghoulish
definitely take that out.
Bristle. He reminds me of the Lego movie, Ventriloquist. I'm a dead guy now. Like flies away.
Well, I think that's going to do it for this episode. Thank you all for joining us every week.
Yeah, don't forget to help us out by helping you out with your, you know, Tronics. Makertronics.
Use
Music
coupon
Maker.
code Music Maker during checkout. Get 10% off, and don't forget we got all those amazing freebie deals for each tier. After you pass the other one, you will get all of the other freebies in the previous tier.
Freebies.
Forget that. All of the M0 boards.
Yeah. One last thing. It's not the end of the shows, guys. We have more shows tonight. We have we have show and tell. It's at 7:30 p.m. We'll be there. A lot of Adafruit folks will be there too, and a lot of usuals. We will have Ask Engineer after that at 8 p.m. Eastern Time. Of course, these are Eastern Time with Lamar and Phil. New products, Raspberry Pi news, Arduino news, that sort of stuff.
Secret stuff that's always cooking up in behind scenes.
John Park is on tomorrow. Check him out. Thursday is at 4 p.m. Eastern Time, 1 p.m. Pacific.
And that's going to do it for
We forgot to talk about this stuff.
Oh, yeah.
We have 3 minutes.
Okay, so we've been playing with the DIY camera slider, if you guys remember our past projects for that. Just coming up with some new ways to actually do like the time lapses for builds, and one of the tests that we tried this on was the some of the Lego builds.
This is so much fun.
Yeah, so we'll link to the guide to this, but super easy, little blue fruit enabled camera slider.
Yeah, this is sweet. Pedro did one too. He did the Ghostbusters. So this is really fun. One of the things that makes this so attractive is that it's panning while it's sliding. And the way to achieve that is you kind of need a little bit of extra help. So I'm using a little panning motorized thing. It's called a Syrup Genie Mini. And it's a little device that you put on your tripod and it pans. So it has it has Bluetooth, and it has an accompanying app, so you can quickly set up intervals, that sort of thing. So you can do time lapses like this. So the thing that's making it slide, however, is this guy here, is our Bluetooth controlled slider. And this actually uses a sliding rail and platform that we sell in the Adafruit shop. Uses the Adafruit BLE friend, and a Adafruit motor shield, stepper motor, and this linear bearing supported slide rail in the platform. All the stuff is here. I'll probably link this down below. This project made maybe 2 years ago, right? Something like that?
Yeah.
Yeah. So a lot of 3D printed parts. A couple of people have made it. So if you're looking for ideas on how to use it, because really it comes down to what do you do with it?
Yeah, it's the use case for it.
We weren't using it a lot either. We just kind of used it outside, and it's really hard to get a good thing to shoot. So we figured, hey, Lego builds might be one of the best things to shoot.
Yeah, so the best point about this is it is the most useful as a time lapse slider, because if it's a video slider, you might get some shaking in it. That doesn't happen when you're doing the time lapse, because it'll move over and then take the picture. So the code that we're actually using for this is from Phil B, which allows the slider to run at a longer interval, or for a longer length of time.
That's right.
So we'll talk about it next week, since we're
right a minute. But I hope you guys like that, and I hope that inspires y'all. Yeah,
it's a cool little process. We might actually do a whole video on how to actually use it, since that was supposed to be part 3 and we never got around to it.
Because we couldn't figure out a good use case. It's like, wow,
this is definitely the best
use
case. We will be using this for actual electronic component project making time lapses. This is just a test to figure out all the intervals, figure out how to actually get the lighting, how not to get things to shine, how to position everything.
We used 2 different cameras too, an iPhone and a GoPro. So I hope you guys like that.
Yes, Kirby's saying that somebody used the kitchen timer. That is basically what this is that we're using to do the panning.
And as you can see, it looks like this is what it looks like with no panning. You can kind of pull it off.
But after a while, it gets boring.
It gets boring after a while.
And you get out of frame after a couple of slides. This way, you are clearly focused and you maintain the framing of the object that you want to look at.
That's funny because we were showing this last week, the Batmobile, and I was all excited, and then I built it the day after. So super fun. It was
Yeah,
about
so
an
it
hour or
basically is, like Kirby says, it is like a kitchen timer, but it's a Bluetooth controlled slider with angle and like
yeah, you
the
can
intervals
set where
figured
you
out.
want to,
And it's super.
It's pretty in depth.
It's
To make that DIY would have to start your own company, get some capital, and like you know what I mean. Like it's a lot of
too much,
man.
It's too much to do that.
But hey, the whole point is about using it.
Yeah.
So. Yep. That's going to be it. It is now 12:01. Thank you guys so much for joining us. Halloween is next week. We actually get to do the show.
A day after Halloween.
A day after or the day before?
I think it's after.
Oh,
I think it's on a Tuesday next week.
Right.
So
well, Pedro's going to be Gordon. I'm going to be DJ NeoPixel or something.
Actually, no, I'm just going to put my helm on.
Oh, your helm?
But you can't see the Daft Punk.
Probably
something.
the Daft Punk.
I don't know, something simple.
I'm just going to wear
Since
my
I got to walk around
NeoPixel headphones. Yeah, I'm going to put my headphones on, put my hat on, you know, NeoPixels all over the place.
Yeah,
we'll have our chair, NeoPixel chair that you made. We'll probably bring out all the projects.
So you'll have about a week to print out any of this year's little Halloween-inspired projects.
Yes.
Definitely go out there, get your hands dirty, add some electronics to any of those reprints.
Yeah, and we'll see you guys tonight.
Yes, Christmas is what we're working on next.
Yeah.
As soon as Halloween's over, we got to get that tree up.
Gotta get those trains.
Right,
Thanks, guys. We'll see you later tonight, and good luck with everybody's making, and be safe. Bye, everybody.